Feel ready? Okay, we'll launch into it. Oh, it looks like somebody put something in here. Yeah, no audio. Hopefully no. Right. Yes, we via Zoom. If the folks on Zoom can't hear us, let us. State University. Thing on their Master of did that.
No need.
I'm
Gonna get rid of this little pop-up real quick. I'm using the extended screen instead of duplicate, so please excuse any pauses as I try to see what's going on that screen. Hello, my name is Joe Klein. As you mentioned, I am the data and visualization or a data and visualization librarian over at Hill Library, but we also have folks at Hunt Library as well. And I'm going to be talking about data visualization today. Can everybody hear me okay? First of all, perfect. There we go. All right, so in this session, we're going to be focusing on how to use design principles to create effective visualizations that fit the needs of your data, your audience, and your research or goal. So I'm going to cover a bunch of resources and tools that are at your disposal, as well as these design elements. And hopefully there will be something for everybody here, whether you're just starting out or whether you're already a pro at data viz and visualizing your data for research or other purposes. So my main goals are for you to understand that there are many ways to visualize data. I want you to be able to improve your design skills by using graphic design elements. So a lot of this gets into more graphic design that people, I think, don't formally get to learn. They just kind of develop as you go throughout your research process and make more data visualizations and posters and things like that. And then finally, I'm going to show you how we can get help from the library. So we have a ton of resources available to you, and I'll show you where you can get those. So the first thing is, what is data visualization even? So I'm going to say that a lot. It's exactly what it sounds like. It is a way that we take data and represent it visually. So things like charts, plots, graphs, maps. There's tons of different types of visualizations you can make. There's also things like sonification, where you're turning data into sound, and physicalization, where you're turning it into physical objects. So I've seen this really, really cool one where they do, I think, income or taxes or some financial thing, and they represent it with grains of rice. And it's over different countries or people who make more than others. I have a very bad memory. But by the end of these rice piles, there's one at the very beginning that has one little rice grain, and by the end, you've got like this massive pile that doesn't even fit in a gymnasium. So it's a really effective way to just show the scale of things. So humans have a hard time with zeros. We have a hard time seeing scale. The bigger the number gets, the harder it is for us to tell. And by bigger, I mean literally the more zeros. So it could be a really, really tiny number too. So data visualization helps us to see patterns, to see those zeros, to get a better idea of what scale we are looking at. So they can include things like line graphs, bar charts, bar plots, column charts. I kind of use a lot of these interchangeably, so don't worry about the terminology as much. And then things like this plot, which is pretty cool. I think that's showing like sine waves. But why do we visualize data as well? So we make data visualizations to share key points about our data, about our research, things that we are collecting or gathering. Sometimes people want to tell a story about something using that visualization. They want to compare things. So if we're comparing between categories of things, and just in general to help aid understanding. I'm gonna make sure I drink some coffee. I talk really fast, so if I get too fast, please raise your hand and let me know. Primarily, we use it, again, as I mentioned, to see patterns. So this is an example data set called Anscombe's Quartet. I think it's Anscombe. It's an artificial group of 4 data sets that he made, which I think is pretty cool. So you've got, there's the mouse. You've got the first set here. You've got X and Y. You've got the second set, X and Y, third and fourth. Visually, you know, it's a bunch of numbers. I can't really see what's going on here. The important thing about this quartet of data sets is that they all have very similar statistical properties. So their maximums are very similar, their minimums are very similar, the averages are very similar. But when you actually map them or graph them, plot them, they look very different. So you can better see outliers like this little dude down here. You can see some of them, even though they've got the same trend, the points are drastically different or have a very specific kind of curve to them. You may notice, I think in this fourth one, this entire column is all 8 until you get to this 19. So that bit is a little bit easy to see because it's breaking the pattern of 8s. So visually, it's a lot easier to see this 19, but for the rest of these numbers, it's almost impossible. You'd have to spend a lot of time reading this. Versus these charts, it's right there, it's quick, and those differences become clear almost immediately. So again, data visualization is about pattern detection, comparison, finding outliers, and overall quicker analysis, but not necessarily just quicker, but more efficient, more effective. Because quicker is not always better. All right. How do we visualize data? So I've covered what it is, why we do it. There, unfortunately, is no one workflow or standard for creating data visualizations, and that's something we struggle with a little bit when we're trying to teach it too. So there are tons of tools available, tons of different programs, software, online tools. You can even just and everybody kind of designs a workflow that works for their specific process. Some people like to look at their data visualization before they collect their data. Some people collect their data first and then play around with what charts they might use. And some people wait and save it for the very end of their paper when they're almost ready to publish, and then they throw their graph in there. And all 3 ways are completely valid ways of doing it. But so these steps aren't necessarily steps that go 1, 2, 3, 4. They're more parts of the entire process that you will run into as you're designing a visualization. So some key things, it's not just about the data. You also want to make sure you're identifying your purpose for why you're making your chart. So a lot of times when people get stuck, being able to go back and look at that purpose can really help you figure out what your next step is. So identifying your question, like what question are you even trying to answer in the first place? Or are you trying to answer too many questions with one visualization, which is something people run into a lot. You want to look at your goal. So are you trying to convince people of something? For example, if you're making an infographic in a poster, or you're trying to get somebody to, for example, call their senators or things like that. Are you trying to just share your research or some other goal? And then your audience. Are you publishing this in a scholarly source or like a journal? Are you publishing it on social media? Does it need to be accessible to a broader audience, or does it have to be more specific to things like your colleagues in your field or your peers in your field or an adjacent field, things like that? For your data, you collect, you clean, analyze that data, or just select an existing data set. That part, I think, is more, not necessarily easy, but typically you will analyze that data regardless of whether you're making a visualization out of it. Next is going to be design, and these are going to be some of the things that I'll look at today with y'all too. So choosing visual design elements and applying best practices for how to make things readable specifically. So readable quickly and also aesthetically pleasing. So that's not always the most important when we're publishing, especially for research, but it can really help get attention, and it can help your audience actually be engaged with your research and with your results. And then finally, tools. So being able to identify software and build those practical skills. So this is what a lot of the workshops at the library sometimes do. We'll focus on one tool like R, Python, Tableau, and then we'll go through the steps of how you can make specific charts. But often those workshops aren't really super helpful for the very, very specific use case that somebody needs. So if you need to do a very specific thing with your chart or your graph, that's usually a process you have to do on your own or in a one-on-one consult type of thing. So I'm not going to cover how to use tools. There's too many to go into, but I will show you a bunch of the ones that we could potentially use and where to find them. All right, so data viz, much like research, is an iterative process. So that's one thing we try to tell our students that are coming to these workshops, especially the introductory ones where you're just getting started out making charts for research especially, is sometimes the chart you start with, often the chart you start with is not the chart you end with. You will likely have to go back to the drawing board and keep trying and maybe tweak a couple things here and there, much like your actual research. So your research question might change depending on what sources or what background information you find, or it might not, and you might get lucky with the first chart. So another thing I want to mention here is you don't really need a digital tool. You can also just use pen and paper and sketch. So when you're first starting out, just sketching out what you want to see and trying a couple of different types of charts, a couple of different groupings, like with these grouped bar charts down here, can really help get a feel for what data you'll need and how you'll need to organize it or clean it up in order to make your charts. Okay. So well-designed visualizations, well-designed here, I'm going to use to mean, effective visualizations that look good, that somebody might see and go, wow, I want that in my paper. Well-designed visualizations take advantage of design elements that are compatible with the data being used, compatible with the question, the audience, the goal. So they take into account those things. So here's an example of what two different charts, two completely different visualizations, but using the same or very similar data might look like. So the chart on the left uses or is showing total emissions, total, I want to say, I'm not sure which emissions. There's a lot of information still missing from this chart with annotations and context, but it's showing a carbon footprint by country in 2021. And it's looking at the total carbon footprint or total emissions. It uses a color gradient as its scale, and each individual country is colored in based on those emissions. On the right, we have 2 feet. So they decided to play with, the carbon footprint and make them feet. So it's an interesting, I guess, visual metaphor for what they're actually looking at. So one of the feet shows total emissions, and then the other foot is looking at per capita emissions, just so you can get a comparison of which countries maybe have higher total emissions, but when you actually look at it per capita, it's maybe a little bit lower impact for that specific country. You'll notice on the right one, I don't know if you can actually see it depending on which screen you're looking at, but there are actually no numbers on the one on the right. There are numbers on the one on the left. Those colors represent numbers, but the colors on the right side represent continents or specific regions. So I think like they have Asia, Europe in there. Instead of numbers, we are using the sizes of the circles to represent how big or how little those emissions are. So without even seeing numbers, we can get a good idea or compare those countries or compare those data points, even though we're not seeing the data points themselves. There's also a lot more annotations on the one on the right, a lot more colors. That's something you might see more in like an online media site or things like Wall Street Journal, New York Times, I think, posts a lot of these. I forget where this specific one came from. versus the one on the left you might see in a paper, especially online, with the color. All right, so I'm gonna look at another example. So that was one, but I'm gonna walk you through an example of how we might take a chart of data, a table of data, and turn it into a data visualization, and what visual elements we would want to consider when we're doing that. So let's say I'm a librarian working on a paper. I'm writing about workshops for a journal, looking at undergraduate research or undergraduate students. I want to use last year's attendance data. So these are some workshops that we offered. This isn't real data. This is made up data. So I want to use these alongside maybe some survey responses, some other data to kind of get a better feel for what topics undergraduate students are interested in. Maybe I can use it to, in addition to publishing it in the paper that I'm writing, I can maybe show it to our library head to see if they would be willing to, fund another workshop or to get better feedback or convince the higher ups that I would like to do this specific workshop. So I could also use this outside of publication too. So this table in Google Sheets, I made it in Google Sheets. It's difficult for me to parse as is. It's not as complicated as Anscombe's quartet, where there's not as many numbers. But I still want to create a visual aid or a graphic for this. So I'm going to click escape real quick and open up a new Firefox tab. Didn't realize it was already up. And here's that part with the duplication, y'all. So just really, really quick, I'll show you how we can make a chart in Google. So Google Sheets is one of the first tools that we like to look at because in theory, everybody at NC State has access to it. There we go. So if you type in sheets.new, it will give you, I might not have time to log in and do all of this. Yeah, all right, so we're gonna skip this part, but just know that Google Sheets is one of those tools that you can use, especially when you're getting started with visualizations and you haven't done it before. It's pretty self-explanatory, not the most intuitive tool, but for the most part, it's all pointing and clicking. There's no coding or programming you have to do, so it's a lot less intimidating if you're just starting out. And especially if you want to just sketch out a chart and get a feel for which ones you should use. So they have some cool recommendations for charts too. All right, and I don't think I messed up the screen sharing, so hopefully the Zoom is still going okay. So instead of that, I'll just skip ahead to this slide. So this is an example of a stacked bar chart that Google Sheets just automatically generated when I put that table into it. I did select the 3D button just to get that example of 3D, but they have since stopped suggesting 3D charts, which I'm very happy about. That's a personal pet peeve, which I'll come back to too, is 3D charts are not the most effective. They can make it a lot more difficult to see where the axis is and where your data ends. And Google Sheets has this fun bug where even if you've got 0 data, oops, for a specific thing, see that go. Even if we've got 0 for a specific data point, it'll still show that color on this bar. So even though we have no undergraduates represented on this little guy, it still shows a light blue square, which can be a little bit misleading if you don't spend more time looking at it. And the goal is to spend as little time as you need to look at this chart. Okay, so there's a couple things that not necessarily are wrong, but aren't the most effective way. So for example, if you look at like the workshop titles down here, several of them are cut off. So several of them are labeled dissertation prep, and you don't know how which of the 3 are which one. Additionally, you have to like tilt your head a little bit to look at that. There's a lot of colors going on. If you're looking specifically at undergraduate students, it can be a little bit hard to get that focus in there. So the very first thing we can do is going to be what I call focus. So I'm looking at the 4 visual elements that I'll be looking at are focus, color, text, and type, and then I think chart type as well. So focus-wise, if I'm writing my paper on undergraduate students, I want to show information about that. I probably don't need graduate and faculty and staff in here. So I could take out those 2 series if we are not comparing them. So if I wanted to, compare undergraduates, if my question was about comparing graduate students and undergraduate students, I would leave those in. But otherwise, I want to take those out. Another thing we can consider is whether to keep zeros. So this kind of gets a little bit more into like statistics and the mathematics side, which I am not the mathematics side, I am the design side. So we might consider taking out zeros, so things where there are no undergraduate students, but that is also a little bit of important data for us, as we want to see what topic students aren't interested in to help us inform us on what they are interested in. We could also order this by size or quantity. And don't worry, I'll show you an example of these changes I'm suggesting in the next slide. We can also order them by size or by quantity, which can help us if we're looking for the top workshops. They'll all be on next to each other, so I don't have to keep looking around this entire chart to see which are the top 3. And then finally, we can remove this 3D effect. It's more of a style choice. A lot of the design elements I'm going to be talking about are style choices, which can be a little bit I think the word is subjective, not objective. The one that's a personal choice or an opinion. But there are some design standards, I think, throughout the field that you'll see. Okay, so here's an example of those. It's already very, very different. So we've only done 4 things. We've ordered these. We've removed 3D. I've kept only undergraduate. You'll notice the title hasn't changed. We haven't done anything to the text or the annotations. Haven't done anything to the color other than remove the extra 2 for the other series. And already I can really quickly, if I want to know the top 3 workshops, boom. The only thing is I can't read their titles yet. So this one, we're not going to do any changes, but chart type can be a pretty important thing to look at. You want to consider what type of data you're working with. So if you're working with, if you want to make a map, you'll need location data of some kind, like a state, a city, coordinates. If you are trying to show a very specific chart, sometimes you'll have to do some conversions between your data. So making things like summary tables so that you can get, for example, counts of workshops. You also want to think about what you're trying to show. So here's where that question comes into mind too. So with focus, we wanted to look at our question of, specifically, what are the top workshops that undergraduates attended? That train of thought is gone now. If you were trying to ask specifically to compare undergraduates and graduates, you might choose a different type of chart. Bar charts are going to be the most common one you'll probably use, especially starting out, and especially with things like survey or demographic data. There's, I guess, 4 in this chart. There's a lot of charts about charts. In this one, you'll see there's kind of 4 functions or things you might use a chart for. So comparison, looking at distribution of your data, looking at composition of a whole, things like that, or even looking at relationships. And it can be kind of difficult to figure out which chart to pick because much like tools, there are so many. So one of these resources that I have on these slides, and I'll share the slides too to go out, has a list of a bunch of different types of charts and visualizations. There's tons. And you don't have to use one of these. You can also make your own, like that footprint graph plot chart. So this resource, if you click on one of these, will show you an example. So this box and whisker plot, it gives you an example of what it should look like, a description. The anatomy part can be pretty helpful because it shows you what different parts of it are. So if you're, for example, recreating a box and whisker plot in R, and you're not sure how to generate this line up here, you can look up that specific term along with R. So what does that say? Like upper, can't read that word from here, but you could find specific resources for how to do that using this anatomy image, which is, I think, pretty helpful. Another thing, so here's another reason I wanted to show you all this, is the tools that you can use to generate this visualization. You'll note there's, again, a lot. And they have varying difficulties or entry points. What am I looking for? Learning curves. Different learning curves based on where you're coming from. So some are code-based. If you're more familiar with programming, they'll be a little bit easier to get started, maybe. Some of them are web apps where you don't need to download anything. Some of them are desktop apps. Some of them are free, or some of them are not free. Like Tableau is very much not free, although I think they do have a free version. There's a lot of tools, and this will link out to those resources of how to learn those specific tools too. Tiny little X. All right, so that was an example of that resource, that catalog, and the other one is much very similar as well. Yeah.
I just want to double check. I think the Zoom sharing, I'm not sure it's capturing the whole window that when you're showing it.
not just that.
Yeah, not just the, yeah, I think it may be doing that. So
Oh no, did people miss
so
that?
screen 2, I think, is what we probably want.
All right. Sorry about that, Zoom folks.
That's my fault. Sorry.
No, you're good. All right. For folks who did miss that, that's the data visualization catalog. And if you pop it into Google, it probably shows up pretty quick. So Google Sheets already picked a bar chart or stack bar chart for our specific data set. It's categorical data. We're looking at categories or those workshops. They're summarized by discrete numerical data, so specific numbers or counts of attendance at those workshops. The chart works for a purpose, so it's going to stay a bar chart. I don't want to change that. I'm fine comparing across categories. Some more options for representing data. If you're not sure what chart type to use, you can also just go straight to the specific elements. So you've got lines. So from most effective to least effective, most effective meaning, you know, how accurate is it? How quick is it for you to be able to look at the data and compare between different points? So position on a common scale or along an axis is the most effective. That's why our bar chart was pretty good as far as being able to see where the top 3 workshops were. And as you go down this, you'll notice 3D's at the bottom. It gets a little bit harder to see. Things like angle are here too, so we use this in pie charts. And then there's color, area, volume, and more. There's others for categorical data too. So things like colors or shape, where you're not quantifying the difference here, just showing that they are different. So you can make your own custom charts with those as well. Keeping track of this mouse is fun, y'all. So we've looked at chart type, I've looked at focus or focusing our data in on one thing. So now let's look at text and typography. So we do have some changes to make to my example chart here. So questions you want to ask are different parts of your graphic easily identifiable and readable? So this is a pretty big one. You'll notice in this example of COVID cases, new cases per day in Raleigh. I forget what year this was for. So we are, again, still missing annotation data or information about this chart. You'll know the title is bolded. It's at the very top left where we would expect the title to be. There's a subtitle underneath it, which tells me it's still relevant, but it's not a part of this title. So I might be looking for things like location, a question that somebody asked on a survey, things like that. The axis labels are gray and smaller. So basically, it just guides your eye around this chart. So you're going to look at the bolded, bigger text first, maybe the colors first. They made this trend line a darker version of red or a darker shade. So you're more likely to look at that line first. And then you want to think about whether your text and spacing is consistent. So consistency is also pretty important, especially if you are, for example, writing a paper or an article that's going to have multiple visualizations. So having that kind of cohesive text standard, I think they call it a type system, can be pretty helpful for, as your audience or your viewer is going from chart to chart, they can get a better idea, or they know where to expect certain parts of your charts to show up. So if you have like a caption down here, and then in the next chart you have it up here, it might be a little bit more complicated or confusing. All right. You also want to do things like avoiding slanted text. So this is a story I tell in this workshop every time. But I was one of the only students in one of my undergrad courses that actually used diagonal text, apparently. So I could always tell whenever my professors got to my paper and started grading, because they'd all start turning their heads sideways. So I don't use slanted text. Sometimes it's unavoidable. Sometimes you can't use horizontal or vertical text. With bar charts specifically, there is a small hack that's pretty cool that will let us make it horizontal so we can read it easier. But I think that's one of the only charts you can do this with. So for our changes for this, for text and typography, I want to update the title. So we no longer have faculty and staff and graduate student data in here, so the title's not even accurate. I want to make it bigger so that it's more readable, and we know that it's the title right now. It could be an annotation just missing an arrow. I want to add emphasis, so I want to make sure those different parts are identifiable. I want to maybe make the axis labels a little bit lighter, or at least these guys. The numbers aren't so important. Important enough for us to keep the numbers so that we know that the scale is accurate. But as far as what I want my audience to get, I just want them to know that this one is bigger than this one. I don't need to know by how much, versus in your charts, you might need that. We could also directly label our data, so we could even remove these grid lines. So this is what we call extra visual clutter. It's just another visual thing that you have to take in and process before you can understand what's going on in the chart. And that does take up mental processing power. So the more of that you remove, the easier it is to process an image and understand what's going on. And then finally, we want to fix these guys and make them horizontal. So we can do that for bar charts just by turning it. So making an actual bar chart instead of a column chart that goes vertical. And this also lets us word wrap our text. So if a workshop title goes a little bit too long, it can just pop down into the next line. So now we see all the workshop titles. I've directly labeled my data so I can get rid of the axis or the grid lines. I still have the axis here, so I still know where all of these bars start. They all start at one line, so I can compare them easily. I have directly labeled these, which is especially helpful for when we get down to zeros and ones and twos. The smaller the bar, the harder it is to differentiate. And again, it's still easy to tell that these top three, because I still have this sorted, are our top three workshops. And again, the title is bold. So we've got the title where we expect to see it, and it is bolded. So we're going to look at that first. Then I'll look at my bars and say, oh, it's this big one, recording booth orientation. The final fourth design element that we can take a look at is going to be color. So this one is kind of one of the most important ones. I save it for last because it can be pretty effective. If you're printing in black and white, for example, in a paper or something that's going to be printed in a newspaper, it's a similar concept, just instead of using hue, you're going to use saturation and brightness. So there are those three things for color. So I'll come back to that. But questions you want to ask for color are going to be, what do you want the viewer to notice? What, after the text, the title text that's bolded, what do you want them to look at next? And then finally, is your graphic accessible to your audience? So this is a big one with color. It's one of the easiest things to check for too, which is pretty nice. It's one of the only things you can actually check off of a checklist is, are you using red and green together? So folks who are colorblind and a lot of, it's a decent chunk of the population, can't see red and green or certain other combinations of colors. So there are some colors you want to stay away from. Unfortunately, we tend to use red for bad or down and green for good or up, especially in business. So you'll see a lot of charts that are technically not accessible. If you were to print them in black and white, or if you were to be colorblind, or if something were to happen to the saturation on your screen, you might not be able to tell which ones are which color. I think most of the business charts that I'm thinking of also use direction of arrows in addition to color to indicate what direction you're looking at. So if you're using red and green and you can't avoid it, try to use some other visual element and add it in so that you can still tell. So there's an example later that I'll show you that uses patterns to fill in the bars instead of color. So you'll see that commonly a lot too. In this example, we started out with all the bars are different colors. It's not necessarily wrong or a problem. It isn't really necessary. So these bars here are referring to years. It's interesting they chose a bar chart instead of a line graph since we're looking at continuous years, but it's still okay. The problem with these colors, though, is, this yellow on a screen is a little bit harder to see. On a monitor, it's much brighter. And this teal color is so bright and saturated, like my eye is instantly drawn to that one point, which was their goal. So they did that. Just these other colors, it's a little bit confusing. It adds one more element of, why am I looking at colors? Is there something I'm missing? Is there another point that the author wanted to make? They weren't. So we could, in theory, make all of these bars gray. And that says the exact same thing that the first chart does, except it takes out that whole question of, what am I looking at here? And even better, they did want to highlight this, I think it's 1995. So making that one a different color, for example, red. In this example, I just chose Wolfpack red, can draw your attention to that one specific point, especially if it is significantly different from the other bars. There we go. There's a lot of resources for color, and I put these in here. They're pretty cool. So Coolers is a palette generator. And it looks like it's sharing it in the screen share. Cool. So hopefully y'all see this time. There are some pop-ups. It's one of the freemium tools that you can purchase a subscription to, and all the pop-ups go away. So that's kind of annoying. But basically, if you press your spacebar, it gives you a palette. If you like a color, you can lock it, press the spacebar again, and it'll give you more palettes with that color, varying degrees of success. But the most important part is it gives you the hex code for this color. So when I copy it, I can paste it into Google Sheets, into Photoshop, into any other tool that I'm using, and have those very specific colors that I want. Color Brewer is a similar thing. Coloring for colorblindness has some examples or some example palettes that are colorblind friendly. I can't show you this plugin. I just realized I'm not on my laptop, but there are Firefox plugins or add-ons, things in Chrome too that will kind of simulate what it might look like. And then there are contrast checkers as well for accessibility. So I don't think this one would pass. I think that gray might actually be the same contrast as the red, but it's hard to tell. Okay. So when we're referencing color, when you are ready to style your visualization, here's that hex code again. Where's the mouse? There it is. There are a bunch of different ways you can reference color. Hex codes is the most common one for especially digital art. RGB is similar. Hex and RGB are interchangeable. It's just looking at the red, green, and blue, or the amount of red, green, and blue is in your color. CMYK is more relevant if you're going to be printing your visualization. If you're using a print medium or if you know it's going to a print journal. Those refer to ink colors. If you are familiar with printers, usually if you're out of magenta, it will not print. Then HSL and HSV. I haven't used those personally. I'm sure other graphic designers have. So here's what these, basically what you would probably expect to see, especially in Google Sheets or any other tool that uses a color picker. I think this might be from Paint or paint.net if I had to guess. So you've got your hue, you've got your lightness or brightness from black to white, and then you've got a saturation. So unsaturated colors are more grays, and you can kind of choose between all of these. You'll see there's your, this is where the duplication would really come in handy. I think that one's the hex code. You've got your HSV and HSLs down here, and then there's RGB and some other things in there. So if you only have one of these numbers, you can usually convert it to another one. So don't panic if you only see, for example, HSL. You can usually convert it into a hex code, is why I mentioned this. So here's some just kind of cool graphics of how those are represented. So the color models are all very similar. This one here directly corresponds to this one, where each of these squares is the same square as the color picker. So I just think that's kind of cool. So with color, with our chart, it's kind of similar to the other example. We don't really need to change the color of these. It's pretty easy to tell the top three. I could make these gray and nothing would change. But let's say I was really specifically interested as I do this, remember it's an iterative process. I noticed that the second most attended workshop attended by undergrads is dissertation prep making figures. And that stands out to me because normally dissertation prep, I would expect graduate students to want to attend. So if a lot of undergraduates are attending that, so what's going on there? So in my paper, I'm going to write about that. So what I'm going to do is I'm going to highlight that specific one too. So if I want my audience to look at dissertation prep making figures, I can highlight that again with Wolfpack Red to really draw their attention to that. Versus in my paper, if I was just going to talk about all of them, I could leave them all the same color. All right. So one more note too. So now we're ready to export our chart. If I'm going to be publishing it in a digital format, I might copy paste it. I may embed it so that it can stay interactive and updatable. If I want to print it as a manuscript or send it, for example, add it to something, I can save it as a PNG, PDF, other image types. I want to make sure I'm paying attention to the size of my chart, the format of my chart. So if you download something as a JPEG versus a PNG, one of those will let you have transparent backgrounds. It's not JPEG. Some of them are more easily editable for others. And I mention this because sometimes you'll have to edit for publication. A lot of the charts that you'll see, especially in things like Wall Street Journal, New York Times, they're made by a team of people who include data professionals, data scientists, and graphic designers. And they are typically using more than one tool. So they don't just stay in R and then from start to finish. For research papers, a lot of people can just use one tool and that's sufficient. But sometimes you will have to pop it out into Photoshop or Illustrator, even Paint, paint.net, to edit some things like captions, annotations, colors, maybe even, and others. So using things like publisher guidelines can really help. Here's an example checklist from Elsevier, which is one of the bigger publishers, or bigger, bigger than a publisher. But so things like file naming structure conventions, what size fonts you're using, and what font you're using in the first place. So maybe I made my chart in Roboto, and I have to make it an Arial. So crap, now I have to go back. I don't want to go back in R and redo all that, but maybe I could put it into Paint and make some changes so that it's consistent. So here's an example of what that might look like if I'm manually editing something after I generate and export my chart. This is also that example of if we're printing in black and white, here's a way we can avoid using color, is just by using different patterns. There's also some type systems that have been added here. So we made our title a little bit bigger. We made our key a little bit more readable, and changed our little annotation here. So in general, it's a little bit easier, quicker to read this. Say, all right, we're pointing at this guy for some reason, and then read the chart. Okay, finally, and I'm almost done, I swear. How do you get help? So I'm from a department at the library. It's called Data and Visualization Services. We do workshops, we offer instruction. We also do one-on-one consults or consultations. So we have a bunch of data science consultants, which are graduate students who are awesome and way better at making visualizations than I am in R and Python and different tools. So you can get drop-in assistance. There is a chat. You can just do it in person at Hill or Hunt in either of the data spaces or the data experience lab. You can email us or just schedule a consultation. And we also do this virtual. And that is go to ncsu.edu/getdatahelp. So if that's the only thing you take away from this, get data help is how you can get data help. There's also workshops. So we have a number of data visualization specific ones. And those are the ones that do go a little bit more into step-by-step, how do I generate this thing in R or Python or a specific tool. And those, I think, go up at the beginning of each semester. So, and then finally, I'm going to show y'all the data visualization page on the library's website. So if you Google NC State University Libraries like I do, it'll pop up for the homepage. And then you'll see a data and visualization tab. Come on. Oh, no. So all data and visualization, you can pick a subtopic within that or just go to the general one. Basically, if you need help with any part of this visualization process, whether you're collecting your data, analyzing it, finding it, wrangling it and cleaning it, or actually generating your visualization, we have a bunch of resources that can help you with that. So there's materials for workshops. Somewhere in here, there is a list of tools. Nope. I'm really good at clicking on things, y'all. There we go. Somewhere in here, there's a list of tools and example graphics, as well as where you can get help with things. All right. One other thing, one last aside is if you would like to learn a specific tool. So let's say I want to do Python data visualization. Some keywords you can use are things like cookbook, workbook, guide, tutorial. No article results here, but as I keep scrolling down, something else might pop up. There's usually some LinkedIn Learning video courses. So these are pretty interesting, I'll say. There's a lot of LinkedIn Learning videos about specific data viz tools of varying degrees of helpfulness. And then as you scroll down, there's more search options, but workbook, cookbook are two keywords that you might want to use. Where is this mouse? There it is. Cool. All right. So that is all I have. We looked at what data viz are, why we use them, how we might use those for color, text, and type, chart type, and focus to kind of edit or improve your chart, and then how to get help. Any questions? Here. Oh no, it looks like the audio might have gone out at some point. Did it come back?
Oh, did it? Oh, I did. Yeah.
It's just the chat saying the audio is back.
Oh. Is there any other questions in Zoom as well? I see some Q&A. I don't know if that was the comment about the audio. Click up here where it says Q&A.
Yeah.
Oh, that was the same one. Oh, okay.
Yeah.
Got it. Okay.
Yeah. Oh, yeah.
Thank you so much for the presentation. I have one just quick final question. Are you going to give the access to us to for this presentation or?
Yes, definitely.
Links to share, like,
Yeah. Exactly. And that's my bad too. Normally I have a link on the bottom that you can get to it, but I forgot to put that in for this one. So
Should we go to the or like through the email they're going to get?
We can put it on Moodle, and if you're okay with it, there's also a spot on the EDC departmental website where we can
Yes.
test recordings. We can put that there as well. It's even more public.
absolutely, yeah.
We'll do both.
And I'll probably do like a go link for go.ncsu.edu / like ECEviz.
That works. Yeah.
All right, let's see, maybe a question. So nice presentation. Thanks for sharing the resources to think about the types of charts to create. Do you have thoughts on how to create high dimensional heat maps? What's a good number of variables for displaying something like that? That's a great question. I know absolutely nothing about high dimensional heat maps. I know generally a rule of thumb is the fewer variables, the better. So as few variables as you need in order to show what you're trying to show. I want to say things start to get hairy after like 5. Yeah, I don't know much about heat maps, unfortunately, but that is a question that you could definitely get answered by one of the data science consultants in one of those one-on-one consults. I think that answers that. Let me know if it doesn't.
Yeah, so from a design perspective, what we're looking kind of like reading things on the screen versus print it out on a poster. Are there any considerations that would be good to in terms of font choices?
Ooh, font choices, yes. I think the general rule of thumb, like the ones that Elsevier had on there, this guy. So the ones they list there, Arial, Courier, Symbol sounds wrong, Times New Roman, those tend to be better. So things like the sans serif, I think, fonts, especially for if you're printing and you're gonna have like really tiny font. Other than that, I know for presentations, the recommendation is like 18-point font is your smallest. And there are a number of guidelines and things like that if you search for like readability poster. But I don't think there's any just one standard though, unfortunately. Does that answer that?
Yeah.
Any other questions?
Which is really important, and I have to admit I'm very guilty of doing red and greens, so I feel for that. But recently I've noticed that PowerPoint and maybe Google Slides as well have, and I don't remember the term, but it's kind of like a captioning or sort of like an extra label that they're suggesting you use to describe it, supposed to.
And a lot of the programming or coding tools are more like that, where you can customize things and make it look not like an R chart. I want to say, if I was exporting something from R, so like the biggest thing I would pay attention to are like sizing. Google Sheets does a similar thing where when you go to export your chart in Google Sheets, it does not give you a size option. So you have to like manually resize everything. R lets you put in what specific size you want. So I think one of those Elsevier guidelines was make your image X pixels by Y pixels. So using a programming tool or a coding tool can help with that. But you can also resize things in Photoshop, and there's generally a lot of tools. If you need to do a thing, there's probably a tool that'll let you do it. Yeah. Does that answer that? Okay.
Yeah, I'm happy you brought up the idea of coupling multiple software packages together. I think that's something that most people don't realize, that most software systems on